Hi dear student, welcome to the classes. Next, the continuation concepts in the D-block element chapter. The D-block element chapter that almost end of this part. What is that? The next concept is interstitial compounds as well as the alloy formation of D-block elements. The interstitial compounds and alloy formation, they are very important and they are closely, not exactly, they are closely similar to the one each other. That's why I make a combined two concept in one video only. Okay, first if I make separate video, then they are going to confuse. In one video only I am going to clear the what is meant by interstitial compounds and what is meant by alloys formation of the D block element. What is the D block? In that D block concept only we are learning. One thing you see here, in D block element only there are formation of alloys as well as there are formation of interstitial compound. There are so many other elements also is there in the periodic table, but we are learning D block element chapter. That specifically we are going to learning interstitial compounds as well as alloys formation, dear students. Okay, one thing first, it's very simplest the concept. Okay, these concept comes in higher studies, and also these interstitial compounds and alloys nowadays, present days, there are wide applications. There are very wide applications in the present day. What is that? We have to come to know right now. Okay, first one, what is meant by interstitial compound? I will go for this. First one, what is meant by interstitial compound? You see here the name itself tells that interstitial. What is meant by interstitial? Interstitial means, it is very simple, dear student. You see here, these are what for example, these are the D block atoms. D block atoms. These D block atoms. D block atoms are there here. Here they are D block atom, and you see here the space between the atoms. This is space between this atom. This is what you see here. This is space. This is space is called as what? Interstitial space. Interstitial space. Interstitial space. The space is called interstitial space. The compound, for example, this is what iron compound, iron atoms. Iron atoms are occupied in the any of the compound. For example, this is one of the iron. Iron atoms are occupied like this. Okay, there will be some space between the atoms. Space between the atom. This is space is called as interstitial space. Okay, this is space is occupied by some other small molecules. This space is occupied by some small molecules like carbon, nitrogen, hydrogens. There are so many compounds, but mainly carbon, hydrogen and nitrogen. The interstitial space of the D block elements occupied by the small atom. Small, they are very small atoms occupied in the interstitial space. Then they are occupied. This space is occupied. This is space also occupied. This is space also occupied. This is space, this space, and this space. Totally, all the space are occupied by the carbon. Then total this type of compounds are collectively called as interstitial compound. Now everyone understand right now. The compound, the first initially iron atoms are there. There will be some formation of interstitial space. That interstitial space are occupied by small atoms like carbon, nitrogens and hydrogens, and collectively they are called as interstitial compounds. Interstitial compounds. That very easy. Now I will show one diagram in that you see here. Bottom of this in this video only I am giving. In that video, you see there will be some atoms are arranged first linearly, and there will be some space occupied. That the interstitial space formed, that space occupied by the small atom or atoms like carbon, nitrogens or maybe hydrogen. Then it forms the interstitial compounds. Okay, from seeing this diagram, I think everyone can clear this concept. Then, okay, while these interstitial compounds are there, you know what is the use of this interstitial compounds? Why want to do the interstitial compounds? That is very important. This interstitial compounds we are making because of due to, if for example, initially iron is there. the iron having some special property, or it's showing like corrosion property. It's showing the corrosion property, but we are making iron with carbon, iron with carbon, iron carbide. This iron carbon compound, this means it is this one, interstitial compound, iron carbide. This iron carbide compound will be not showing corrosion property, not showing the corrosion. That is what steel is. Okay. There are so many reasons why we are doing interstitial compound. We are doing the interstitial compounds not only for this. For example, some compounds are little hard, but after making or after adding the nitrogen, hydrogen, carbon, they are going to be somewhat more harder. Next one, if some molecules are not dielectric, some they are after adding the interstitial compound like nitrogen, carbon, they are going to the dielectric property or insulating property, or it may be conducting property. Like this, there will be, they are showing the alloys formation. And also we go for this one, example for this one, iron hydride. Okay, iron hydrides. Next, vanadium hydride, like this 0.5. I will tell you what is meant by this 0.5. There will be some examples I will give you, dear students. You see here, this is what Fe3H, next VO5, next technetium hydride 1.7, next one titanium carbide, next one Mn4 nitrogen. You see here, dear students, in these type of compounds, you see here iron hydride, next vanadium 0.56 is there exactly. This one tellurium 1 hydrogen 1.7, titanium carbon, next one manganese nitrogen. These are what alloy formation. These are the what alloy formation. These alloys, sorry, not alloys, interstitial compound. These interstitial compounds we are using for some special property like higher. For example, I will go for that. Initially this iron is having less what is that, less they are having more corrosion property. After adding hydrogen in the interstitial space, this is having less corrosion property. Next, like this corrosion property, and also next higher conductions. Next one higher brightness also sometimes brightness. Next one harder. From these all reasons, there are so many reasons why we are doing interstitial compound. Interstitial compounds we are doing the interstitial compounds only because of the higher hardness, higher conductivity, higher brightness. There are so many reasons we are doing the interstitial compounds. Okay, I think from seeing this one picture I am given, and there are so many examples also I given in the picture you see here. Okay, after seeing that alloys and uses, this interstitial compounds and this one, we are going for the alloys. What is mean by alloy? Next concept is arising. What is mean by alloys? Okay, you see here, dear student, alloys means what? Alloys means it is a you see here, alloys means it is a homogeneous mixture of two or more than two compounds of the d block element. For example, what is meant by this homogeneous alloys? Alloys means, for example, this is what take copper. This copper around I am taking this copper solution, means copper molten solution, and also in this zinc I am taking zinc. The copper and zinc, for example, I am taken this one with whatever it may be. This copper and zinc are there in this two. After adding this one, we are getting to the copper and zinc. Copper and zinc we are adding. They are going to mix. Nodri, henga ಹಾಲ್ನೆ ನೀರು ಹಾಕಿದ್ರೆ ಮಿಕ್ಸ್ ಆಗ್ತದಲ್ಲ ಹಂಗ ಕಾಪರ್ ಜಿಂಕ್ನೆ ಹಾಕಿದ್ರೆ ಏನಾಗ್ತದ ಮಿಕ್ಸ್ ಆಗಿಬಿಡ್ತದ. ಅದ್ರೊಳಗೆ ಏನಾಗ್ಬಿಡ್ತದ ಅದು ಮಿಕ್ಸ್ ಆಗಿಬಿಡ್ತದ. ಮಿಕ್ಸ್ ಆಯ್ತಂದ್ರ ದಿಸ್ ಒನ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ವಾಟ್ alloy. This one is called as what alloy. ನೋಡ್ರಿ ಹಂಗನಂಗಿದ್ರೆ ಎಲ್ಲಾ ಕಂಪೌಂಡ್ ಎಲ್ಲಾ ಮೆಟಲ್ಸ್ ಎಲ್ಲಾ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ ಮಿಕ್ಸ್ ಮಾಡಕ್ ಬರ್ತದೆ? ನೋ, ಇಟ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್. ಎಲ್ಲಾ ಡಿ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ ಮಿಕ್ಸ್ ಮಾಡಿ ಹಂಗನಂಗಿದ್ರೆ ಎಲ್ಲಾರು ಮತ್ತೆ ಇದನ್ನೊಂದು ಮಿಕ್ಸ್ ಮಾಡಿ ಇನ್ನೊಂದು ಮಿಕ್ಸ್ ಮಾಡಿ ಎಲ್ಲಾರು ಒಂದೊಂದು ಕಂಟ್ರೋಲ್ ಬಿಡ್ತಿದ್ರು, ಹೌದಲ್ಲ? Therefore alloys means one condition. That condition is very very important. The condition is very important. The difference between two element, the difference between two element of their radius of their radii is 15%. 15% ನೋಡಿ, 15 ಸೆಂಟಿಮೀಟರ್ ಅಂತ ಹೇಳ್ತೇವೆ. ಇಲ್ಲಿ ನೋಡಿ ಏನಿದು, what is this? That is very important. For example, this just now I am mixing zinc. Zinc having around assume that this first I will take copper around 50 picometer of that radii, this copper radii. Mixing the zinc means must and should be this atomic radii around 40-45 picometer. The difference between these two is around 10 picometer, means 50 minus 40, 10 picometer. If it is 10 picometer, the difference between this is 10 picometer, then it is very easily mix. They are soluble or they are going to mix each other and it forms the compound copper and zinc. ನೋಡಿ, ಇವೆರಡು ಕಂಪೌಂಡ್ ಯಾವಾಗ ಮಿಕ್ಸ್ ಆಗ್ತಾ ಹೋತಂದ್ರೆ ಅವೆರಡಕ್ಕರ ನಡುವೆ ಅಟಾಮಿಕ್ ರೇಡಿಯ ಎಷ್ಟಿರಬೇಕು? 15 ಪಿಕೋಮೀಟರ್ ಡಿಫರೆನ್ಸ್ ಇದ್ರೆ ನಡೀತದೆ. 15 ಪಿಕೋಮೀಟರ್ ಡಿಫರೆನ್ಸ್ ಇದ್ರೆ ನಡೀತದೆ. If difference between the compounds or difference between the two elements is less than 15 picometer, they are going to easily soluble. They are form the new compounds. Therefore, alloys means what? Alloys means it is a homogeneous mixture of two or more than two compounds to form a solution, that is called as what? Alloys. Then after that, alloys formation must and should be on condition that difference between the whatever that elements or any of the atoms, the difference between their radii is must and should be 15 picometer. Then they are called as what? Alloys. That alloys, for example, that one I will show the diagram. How to differentiate the interstitial compounds and alloy. For example, alloys means like this. These are the what atoms. Here what happens? This is copper. Here what one? This is copper. Next copper. Here whatever the space between this one, it is occupied by zinc. You see here, it is not occupied in the interstitial phase. Here they are not occupied in the interstitial phase, but they are occupied in their linear chain, or it may be their main formation of their chain. Therefore, the alloys means the homogeneous mixture, but interstitial compounds means they occupied only interstitial space, dear student. Therefore, this is what difference between alloys and interstitial compound. Then okay. Then why you are doing this alloys? The very important nowadays they are learning material science. This is a wide branch in the chemistry presented a material science. What is this material science? What they are learning, what they are doing in the new research. That is now you have to know what is they are doing. You see here, there are so many cheapest elements or whatever domestic objects are coming up presented in the market. Why they are coming? This is because of due to their alloy formation. Nodri, first iron ಒಂದೇ ಇರುತ್ತಿತ್ತು. ಐರನ್ ಒಂದೇ ಇತ್ತು ಅಂದ್ರೆ it's going to rust, it's going to the corrosion, but we have to mix some compound with that carbon that it form the steel. That steel is not corrosion. Okay, next after that this brass compound, dear student. This brass means copper and zinc. This brass were there are so many, you will see this is brass. Next one bronze. This is what copper plus tin, the copper plus tin. Oh, this is what, there are so many examples what I will give you. See here this compound, you see this table consists of three chart. First one alloys name, next mixture, next one applications and uses what I given. You see here in your exams they are asking what is maybe alloy, given example. At least you have to remember 2 or more than 2. Okay, this is what alloys and compound, and also in that also given what is the use of each of the alloys I given in this chart. You see, observe the dear students. First one, there are so many, and next I will give one best my favorite alloy is alnico. You see here, this is what one of the alloy, alnico. The alnico, this alloy consists of aluminum plus nickel plus cobalt. This is a mixture of this alloy. This alnico compound is the alloy mixture of 2 or more than 2 d-block elements. Nickel is there, cobalt is there, next one aluminum. It is not d-block, but this is one of the elementary in that. What is the use of this one? This is what alnico compound, we are using artificial magnet. Not presently we are not getting magnet, but we are going to prepare a magnet in the laboratory. That is for mixing up 1 or more than 1 d-block element to form artificial magnet. Artificial magnet is man-made magnet, that is mixture of 2 or more than 1. And these some of them, for example this we are going to for copper, bronze. ನಾವು ಹೇಳ್ತೀವಿ ಈಗ ಗಂಟೆ ಹೊಡಿತೀವಿ ಮನೆಯಾಗ, ಗಂಟೆ ಇರುತ್ತೆ ತಾನೆ, ಬೆಲ್, ದೇವ್ರ ಮುಂದಿರ್ಬೋದು, ಸ್ಕೂಲಲ್ಲಿ ಇರ್ಬೋದು, ಇಲ್ಲಿ ಅದೇನಿದೆ ದಟ್ ದಿಸ್ ಈಸ್ ವಾಟ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇವ್ರು ನೋಡ್ರಿ ಅದರೊಳಗೆ ಬರೀ ನಾವು ಬರೀ ಬೆಲ್ ಇರ್ತಿದ್ವಿ, ಅದ್ರೊಳಗೆ ಬರೀ ಕಾಪರ್ ಹಾಕಿದ್ರೆ ಅದು ಬೆಲ್ ಅಷ್ಟು ಸೌಂಡ್ ಬರೋದಿಲ್ಲ. ಅದ್ರ ಕಾಪರ್ ಪ್ಲಸ್ ಜಿಂಕ್ ನಾವು ಮಿಕ್ಸ್ ಮಾಡಿದೆ ಅಂದ್ರೆ ಅದು ಅಷ್ಟು ದೊಡ್ಡ ಸೌಂಡ್ ಮಾಡ್ತದೆ. ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇಟ್ ವಿಲ್ ಬಿ ಇನ್ಕ್ರೀಸಸ್, ದೇರ್ ಫಾರ್ ಸೊನಾರಸ್ ಪ್ರಾಪರ್ಟಿ. That is very important. And some of the metals are very less hard. They are going to add one or more than 1 alloys, or one or more than 1 d-block element mixing. They are going to be hard. The copper initially it is somewhat less conducting property. After adding some compounds to that d-block element, that copper, where that conducting property will be sudden increases. Therefore, this is what. And one thing, interstitial compound alloys, the most of the uses will be similar, but the concept will be different, dear students. Okay, you see, I will give the 2 diagrams at a time. After seeing this 2 diagram, you compare these 2 diagram. From seeing this diagram, one is interstitial compound, one is alloy formation. Okay, this is what interstitial compound, dear student. After that, this alloys again classified into many types. If you are going for the higher study, it will come to know that. What is this alloys again classified into homogeneous alloy, heterogeneous alloys, next metal. There are so many types of alloys will comes. This is what your PUC section, it is enough. Okay. Okay, thank you for watching my videos, dear students. I think one thing I'll tell you, from this I think videos are, as well as sound problem is there in my initial videos. I think it is not there in presented. I think I brought it this one. I think this sound problem, if any sound problem is there, please comment. I will change, or I will further change in the any mistakes in the sound system. Okay, please, if comment for me this sound system I am making, this is because one of the new one. If any problem, I will change it right now only. Okay, if you like my videos, please share, dear students. And one thing, the fundamental concepts I am discussing, please learn very well. Okay, this is one of the good time we are learning. Okay, thank you for watching my videos. If you like my videos, please share and subscribe. Please amount, it will be helps for any other persons. Okay, thank you for watching my videos.